Hello, I'm Rafael Slavov, and I will present the application of the logistic regression in the supplier's quality management risk analysis. This work was done by myself, by Camila Martins, by Flavia Mariano, and by Luiz Martins, everyone from Federal University of São Paulo, Brazil. I will be presenting the contextualization of this work, the justification, the methodology, the results, what is the conclusion, the restrictions verified during the work, and also the reference used on this work. Innovation and technology are becoming partners in product development and people's life transformation. Customers are demanding interesting and reliable products consistently delivered faster, on time, with no damage, and with good quality. Rapidly changing technology, the complexity of products, and the growth of competition are challenging the original equipment manufacturers, OEMs, to seek suppliers who will provide low-cost products with good quality and a high performance. Some of the challenges in the aerospace industry are the product complexity and the technology applied, products with high reliability and security, the constant work for a cost reduction, the big competitiveness, a reduced team to work with a complex supply chain, the customer demands, a worldwide supply chain, and the authority's requirement for a secured product. Based on the challenge presented, the performance analysis and the measurement of the supply chain shall be done. One way to do that is to rank and select them for improvement. As many factors should be considered in the analysis, the problem can be tackled using multi-criteria models and methods. However, how we can calculate the risks? The importance to have the supplier risks monitored can be explained by the problem experienced by Boeing. A delay in the delivery of its new jet, the 787 Dreamliner, was attributed to the outsourcing strategy adopted, which was more than 70% of aircraft parts were outsourced. Consequently, in 2013, some of the airlines had emergency events during the flight due to a fire caused by the battery overheating of the auxiliary power unit in the rear fuselage. FAA immediately issued an emergency airworthiness directive ordering all USA-based airlines to ground their Boeing 787 until the modifications were made to the electrical system to reduce the risk of the battery overheating or catching fire. The objective of this work is to use the logistic regression method to calculate the risk of a supply chain from one aerospace company. The logistic regression was done considering 201 suppliers. The time frame considered was between October 2018 up to June 2019. 14 variables were considered on the data to be analyzed by the logistic regression. The variable reg total was divided in four categories based on four quarters: no rejection, one or two rejections, from 3 up to 9 rejections, more than 9 rejections. The outcome Y considered the supply performance in the month of July of 19. Good supply performance was considered Y equals 0. Poor supply performance was considered Y equal 1. The intention was to predict the supplier status based on its performance. The Table 2 presents the results of fitting the logistic regression model based on the data presented on the Table 1 before. The variable reg total is the reference due to the lack of rejections. As higher the number of parts rejected, higher is the chance of supplier be bad when compared with the variable reg total. The same for the variable change June 19, which means that the supplier with a change mapped in June 19 had 6.97 more chance to fail when compared to the supply which do not have the change mapped. The overall percentage of classification result in a hit rate of 78.6%. A correlation analysis between the logistic regression score calculated in this work with the risk calculated in the month of August 19 by the aerospace company was done to verify if both risks were converging to the same direction. The analysis was performed using the Spearman method and indicate that there is a statistically significant correlation. The final logistic regression model resulted in 7 groups of suppliers with their risks identified. As highest is the predict, highest is the risk. Based on group of 42 suppliers with predict of 0.672 present in the last table, it was choosing two suppliers, 148 and 181, to analyze how they were classified in the risk analysis previously done by the company. The supplier 149 presented a constant failure rate. However, per the current risk analysis method done by the company, it was not classified in the top worst suppliers. The supplier 181 had a seasonal failure rate scenario that was not identified by the company, which was considering the average of the failures from the last 3 months. A logistic regression analysis was defined to be applied in the current supply chain of one aerospace company. The logistic regression resulted in 7 groups of suppliers with levels of risk. Some of the suppliers from the first group were analyzed, and based on the results, a final model provided indications on suppliers that were facing a bad performance and need to have an action plan to improve their performance. It was identified that some suppliers with high risk were not being classified by the current method done by the company. The verification of supply performance in a long time contributes to identify some cases that even the supplier does not have a high number of rejections, but has a constant rejections. The method proposed can be adapted and implemented by company and will provide as a result the significant variables that need to be prioritized in the supply quality management performance. The application of the logistic regression exists for a long time but have not been applied in the aerospace supplier quality management. It's common to be used in the supplier selection by other companies before the development phase, but not during the production phase. The concept is to choose the right supplier which will not present issues. However, as explained before, In the aerospace industry, in most of the cases, there are a limited sources to be selected. One restriction identified in this work was the limitation on the database available by the aerospace company in terms of time and sample size. As bigger is the sample base, the model would capture a better supply performance history. Small samples may have sampling error, and very large sample size increase the statistical result and decrease the error rate. The second restriction identified was related to the supplier performance analysis instead of part performance analysis. A verification at the part level would provide the exact information on when and how many parts were received and rejected. This would help in a final model error reduction. See the reference used in this work. Thank you for watching this video, and in any question, feel free to contact me.